Inverse of a function, part 2. So we're on example 4, finding the inverse of a cubic function. Consider the function f of x equals 2x cubed plus 1. Determine whether the inverse of f is a function. Then find the inverse. All right, so the easiest way to determine whether the inverse is a function is to use the horizontal line test. So let's graph the function, and then we can visually look at it and see if it would pass the horizontal line test. So we're going to have 2x cubed plus 1, and then we're going to hit graph. And again, remember, you use the vertical line test to see if this one is a function. You use the horizontal line test to see if the inverse is a function. And if it is, if it passes the horizontal line test, that means it is a one-to-one function. So this one does pass the horizontal line test, so it is one-to-one. So it says determine whether the inverse of f is a function, and the answer is yes. The inverse is a function. And then it says find the inverse. So let's go ahead and find the inverse. First, we're going to write this as y equals 2x cubed plus 1. So I substitute the f of x with y. Remember, it's just two different ways to write the same thing. F of x is just function notation. But when we're finding the inverse, to switch x and y, it's just easier to have a y. So we're going to have switch x and y. And then we're going to have 2y cubed plus 1. And then we solve for y. So we're going to subtract 1 from both sides. Then you're going to divide both sides by 2. And then we're going to have y cubed equals x minus 1 over 2. And to get rid of something cubed, we're going to take the cube root of that. Since all of this stuff is already here, all of it has to be under the cube root. So then we can rewrite that as f inverse of x. Remember, that's our inverse function notation. And then we have the cube root of x minus 1 over 2. Example 5, finding the inverse of a radical function. Consider the function f of x equals 2 times the square root of x minus 3. Determine whether the inverse of f is a function. Then find the inverse. All right. Determine whether the inverse of f is a function. So pretty much like what we were doing before, we can use the graphing calculator to graph this and look at it and see if it passes the horizontal line test to see if it is one-to-one. All right, so using the calculator, let's clear the last function and then type in 2 square root of, we've got x minus 3. Then I'm going to hit graph. And this is a transformation of the parent square root function. So remember, the parent square root function is just f of x equals the square root of x. But this is a transformation, and we can see that it does pass the horizontal line test. So because it passes the horizontal line test, that means it is one-to-one. And that means that the inverse is a function. So it says determine whether the inverse of f is a function. So we have done that. We've determined that yes, the inverse is a function. So we have a one-to-one function. And then it says find the inverse. So just like before, we're going to substitute y in place of f of x. And we're going to write the function down and then interchange the x and the y. So to find the inverse, we're going to switch x and y. And then I have to solve for y. So 2's on the outside of this, so we're going to divide by 2 first. So we're going to have x divided by 2 equals the square root of y minus 3. Then all of this is under the square root, so we have to square it. So we're going to square this whole expression as well. So we're going to have x squared over 4 is equal to y minus 3. And then we're going to add 3 to both sides. So I'm going to have x squared over 4. And then I'm going to add 3 to both sides, and that is the inverse. So that would be f inverse of x. You could also write this as 1/4 x squared plus 3. So that's just another way. That means the same thing exactly. It's just another way to write it. With the 4 being in the denominator here, you could write that as 1/4 times x squared plus 3. So you've got this or this. All right, now one more quick thing talking about the domain. So remember when you switch the x and y, x's, your domain comes from your x's, your range comes from your y's. If you look at this, we had a square root function, which restricts your range to y's greater than or equal to 0. All right, so when you do that, then you switch it. That means the domain has to be restricted to x greater than or equal to 0. So hopefully that's not too difficult to understand. If you think about a quadratic function and you're talking about only the positive side of it, if you want it to be one-to-one function, you have to have that restriction, or it would not be a function. If you had the whole x squared quadratic functions are functions, but the inverse of the plus minus square root function would not have been a function. So to start out with a function, we only had the positive square root, which means we're only going to do the positive part of the quadratic function. Example 6, determining whether functions are inverses. So determine whether f of x equals 3x minus 1 and g of x equals the quantity of x plus 1 divided by 3 are inverse functions. So there's two ways to do this. It's both pretty easy. Let's start with taking one function, finding the inverse, and see if that's what the other function is. So to me, that's the easiest way. So we're going to do y equals 3x minus 1, switch our x and y, and then add 1. So we've got x plus 1 equals 3y, and divide by 3. So f inverse of x equals x plus 1 over 3. So that's the inverse. So does that equal x plus 1 over 3? It does. So we can determine that f and g are inverses. So f and g are inverses. All right, so again, to me, that's pretty straightforward. That's pretty easy, and we just found out how to do inverses, so that works. But we also looked at composition of functions. So if we use composition of functions, we can also look at f of g of x and g of f of x and see if we get the same output. And if we do, then we know that we also have inverse functions. So let's say f of g, and this, again, this is just another way to do this. So if you got f of g of x, what we're going to do is take the g function and substitute it into f. So we're going to have 3 times, and here we're going to put x plus 1 over 3, and then we have minus 1 to finish up our f function. All right, so here the 3's will cancel. So we're left with f plus 1 and minus 1. That leaves us with just x. All right, so let's look at g of f of x. And composition of functions is also on the ACT, so this is good practice as well. So we're going to take the function f this time and substitute it in for x in our g function. So we're going to start with 3x minus 1 plus 1, all of that over 3. So these are going to cancel, and then our 3's will divide out. So we got 3x divided by 3, and that leaves x. So you can see that this gives us x and this gives us x. So the composition of functions also shows us that f and g are inverses of each other. All right, math practice, communicate precisely inverse functions undo each other. In other words, in your own words, explain that meaning. So you've heard me talk about it. Probably good to sit down and write that out in your own words so that you can understand it well. Example 7, modeling real life. The speed of sound in meters per second through air approximated by f of x, where x is the temperature in degrees Celsius. Find and interpret f inverse of 340. All right, so the first thing we're going to do is take our function and find the inverse, which we know how to do. So we got y equals 20 square roots of x plus 273. We're going to first switch our x and y. That's how we find the inverse. Then I'm going to isolate my radicals. So I'm going to divide both sides by 20. And I'm left with the square root of y plus 273. To get rid of the square root, I've got to square everything. So I'm going to have x squared. 20 squared is 400. And y plus 273. And then I'm going to subtract 273 from both sides. All right, so I can write this as 1 over 400. So I can write this as 1 over 400 x squared minus 273. And that's going to be f inverse of x. All right, so first I find the inverse. So I've got 1 over 400 x squared minus 273. And then I need to simply plug in the 240. So let's do that. So 340 squared minus 273. All right, to save a little time, I have went ahead and typed this in. You can see I typed in 1 over 400 times 340 squared minus 273, and that gave me 16. So this is going to equal 16. So when 340, or when x is 340, y is 16. So that is an ordered pair that falls on that graph. So what does this represent? All right, so we're talking about the speed of sound in meters per second through the air, where x is the temperature in degrees Celsius. All right, so we're looking at the inverse. So this is going to represent that the temperature is 16 degrees Celsius when the speed of sound through the air is 340 meters per second. All right, that is all for inverse functions. Most important thing, remember, if it asks you to find the inverse, you need to switch x and y and solve for y. Doesn't matter if it's an ordered pair, a table of values, or an equation that you need to switch x and y and solve. Again, inverse functions are something I enjoy, so hopefully you do as well. If you have any questions, please let me know.